welcome everybody to an episode of Automation Ladies. It is Wednesday, October 9th, 2024, in which we're recording this. We are back to recording for season 5. We've had some episodes air on season 5 already that we recorded over the summer. We were at a lot of shows, a lot of trips, a lot of work, and we needed a little break. But we're back to it because we can't help but meeting people that we want to have conversations with, apparently. I was really interested in talking to today's guest, Rob Michael, about compressed air. So welcome to the show, Rob, and thank you so much for joining us.
Thank you. My pleasure to be here. I'm excited.
Rob, you want to tell us, you are in your car, which you are not the first or the last guest to join us on your phone in your car. That is the nature of the work. But you want to give us a little intro about where you're at and what you're up to today?
So yeah, phoning in from the mobile office here for sure. So as we were talking before the recording started, I'm actually at a power generation plant right now. They're in the middle of a big shutdown and just taking care of some of their equipment, rebuilding a couple of desk and dryers that are used for instrument air.
Okay.
Finished up the one just a little while ago, so I turned it over to those guys. They're going to get it unlocked, get it back in service, and get the other one locked out for me. And then once we're done here, I'm going to head back and get on that Lotto box and start tearing into that guy.
Are they using that air for like driving like Fisher valves or like
Yep.
air compressed air valves? Okay.
Yep. Yeah. Fisher valves, whatever cylinders, all that stuff. It all runs off that system.
Got it.
Yeah. So I, even though Rob, you're not exactly an automation guy, what you do touches a lot of what we do. Yeah. And so very pertinent to have the conversation. One of the goals we have at Automation Ladies is to try to ourselves and by extension our audience learn about all the different types of jobs that are in a plant and how they affect automation and controls and all that kind of stuff. And with my background, I worked at Festo for a while, compressed air. I'm a bit familiar with it, but I don't know that it's something that a lot of other people think about. And so when I meet people that are really into it, I think that we have a lot to learn from you. So can you tell us a bit about your journey? How did you get into what you're doing and what did it take to get here?
So yeah, it's like all good journeys, it's got a lot of twists and turns in it. I actually started off my career as an auto mechanic and
Okay.
figured out through that my knack was kind of in electronics and drivability problems, check engine lights, all that kind of fun stuff. And after a while, decided I was going to go do something else. So I went and worked for a local electrical contractor, doing commercial residential work with them. Signed on as an apprentice, went through 4-year apprenticeship, got my degree in electrical maintenance and construction. Stayed on with them until 2008 when that whole bit with the housing market and all that struck. And
Yep.
Of course, being a mostly residential contractor, work dried up pretty quick and found myself laid off. And then that was when I ventured into the industrial electronics world and went to work building some ethanol plants and very quickly worked up the ranks from lowly conduit runner to being the guy in charge of commissioning all the new projects. So a lot of reading blueprints, terminating, ringing out wires, troubleshooting, whatever it took, whether it was a mechanical problem, electrical problem, whatever. My job was to get the machine running. And that was when I lived in Nebraska. That's pretty much where I was raised. My wife is from Pennsylvania. When we met and got married, also in 2008, she came out to Pennsylvania or to Nebraska, where I was for a few years. And after that, after about I think 5 or 6 years and a couple of babies, she decided that she wanted to go back home. So we packed up, came to Pennsylvania, and I had a job lined up with an automation company actually. And the guy was super cool about everything. He's like, "Yeah, just give me a call whenever you guys get into town, and we'll get you set up." And I was like, "All right, cool." And got into town, and I went and met with the guy. And the schedule we had discussed was 5 to 10% travel, and the schedule he handed me was almost 100% travel. And I was like, this isn't going to work out, buddy.
Yeah.
So,
Big
yeah,
mismatch of expectations right there.
Ouch.
right.
That seems to be happening a lot. Like, I mean, that's the bait and switch, right? But like, how is that? Why are they doing it, and how is it working? Like, it's not working, obviously, because like you can just be like, no,
That
I need to
is
see my children.
drastic. I mean,
Yeah, I
Yeah,
don't.
that particular change is huge. I've seen a lot of people get promised like
people
35
have
and it turns out to
families.
be 50. But like going from 10 to like 100 is holy cow.
Yeah, I'm not opposed to traveling, but not 100% of the time.
Yeah, that's too much.
So, of course, I immediately went home and started just dispersing my resume indiscriminately amongst job sites because I needed to find a job. And got contacted by I would say, a mid-sized compressed air distributorship, and they said, "Hey, we found your resume. Why don't you come in for an interview?" And I came in, and I was like, "Well, hey, I've never worked on an air compressor in my life, other than I think I tied into some digital outputs on a couple of them for some monitoring and stuff, but." And they're like, "Yeah, we're not worried about that. We'll teach you that end of it. We want you for the electronic side of what you're capable of, because everything's going to microprocessor controls and variable speed drives and all this stuff, and we have nobody that knows anything about any of this stuff." And so that was where the compressed air journey began. So from there, I've kind of been here and there and everywhere. Like I said, I worked for them for a while, and then went to work for an OEM for a little while. Did my own business for a little bit, and now I'm over here at Cummins Wagner, having a blast with these guys.
Very cool.
You said you stayed in like compressed air jobs, but like that stuff is applicable on like all of the industries. I mean, or even just if you stay compressed air is used in every plant almost.
Everywhere. Yeah.
Indeed.
So it's like you get to touch every single industry.
It's like you have electricity, you have water, and you have air, but I don't think a lot of people think about the air part.
So compressed air is often called the fourth utility, right? Because as you said, you've got water, you got electricity, you've got gas, and probably 90% of the places out there in the world that are actually making anything.
Oh, we lost your audio somehow.
I think we lost your
But I
volume.
was actually going to say maybe there's 5 now, though. Isn't internet pretty much considered a utility at this point? Like, you got to have internet connectivity.
Or connectivity or something. So he is an automation guy. Like he's not an automation guy. We need to like reverse what we said.
Well, he's like currently.
Well, it was
Okay?
interesting because his remark about the guy telling him we can teach you that, like, hey, I don't know this part that this company specializes in, and it's like, well, the company specializes in it, we can teach you that, we need
Well,
the
that's
other
exactly
stuff.
when I went to Festo. They were like, well, we have a lot of pneumatic sales guys that know how to sell pneumatics, but we want to push electric now, and they are not thinking of the electric when they're looking at the applications because their whole background is in pneumatics. So we want someone that
Right.
doesn't have the background in pneumatics so that they don't default to pneumatics.
So they don't go right to that. Yeah,
exactly.
That makes a lot of sense.
And I think it's very smart sometimes to hire for, you have a certain set of skills that are like really necessary, but not the rest of the job. The rest you hire for aptitude, right? Which I guess we're about to find out if that still works on me.
All right, I think we got it.
All right. With audio.
With audio, even, yeah, that was horrid there for a minute. So
sorry about that, and I want to apologize for calling you not an automation guy, because that is, I guess, patently false.
well, I mean, I'm technically not. Obviously, there are guys out there that would run circles around me when it comes to automation and things like that. I've got a good enough understanding of it that I can see how it applies to compressed air, and I have a good understanding of how to tie those systems in with the compressed air system, which I hope we'll dive into today, and maybe give your audience some ideas of how they can be more effective in helping with that, and maybe generate some leads for them, some work for themselves. So
absolutely. Well, why don't I just let you dive into that? What do you want to say about that?
Well, so I mean, first and foremost, like we said, compressed air is a utility, and it's amazing to me that so many of these manufacturing plants and places like that will monitor every utility they have. When it comes to compressed air, they're blind. You can talk to the reliability engineer, he can tell you how many kilowatt hours and all this stuff with electricity that the plant's using. You ask him how many CFM does your compressed air system use, and you get a blank stare. And when you're talking about something like a compressed air system, which is between 30 to 50% of your overall energy consumption for that plant, why wouldn't you be looking at that?
Yeah, that is a lot.
Yeah, like that's just nuts.
And I've
And
had instances where like we didn't check pressure in lines and we'll turn on valves and we're like, we definitely turned the valve on. Like the output is on and then the whole pond is dead. And we're like, oh my God. And it's because there was no air. Yeah, it was open. There was no air being given, but it was electronically saying yeah. And then we didn't
right,
have what is it? Limit switches, so we don't know for sure that the valve really opened. Another reason why the hell would you do that? But yeah, definitely.
I was at a plant where nobody did the math on how many CFM we needed using Venturi valves to pick up product,
oh
like with
wow,
suction cups. And we were dropping product because somebody undersized the compressor that was feeding the 4 lines.
yeah,
So people are like, why are we dropping things? I'm like, I don't know. I turned it on. Like,
yeah. Well, I mean,
Physics.
and a Venturi by itself uses a ton of compressed air.
ton, like
Mm.
3.1 CFM per circuit. And for big products, they were using like 3 circuits, and then that's every line. So it was
Right.
a lot of air. It was a lot of air, and they just undersized the compressor. But it was funny. Stuff was dropping left and right.
Yeah, so
Yeah.
tell us more about like, yeah, what can you be monitoring?
So really, you're only limited by your imagination, really. Um, Most modern air compressors that have that are microprocessor controlled are going to have some form of monitoring. I mean, if you look at like a Solaire, which has air links on it from the factory, so you've got remote monitoring right there. That's it's already built into the machine. All you got to do is activate it.
Okay.
Um, Same with anything from like Atlas Copco or Quincy. The remote monitoring is right there from the factory. All you have to do is activate it. If you want to pull it into your own to the plant SCADA or to the historian, something like that, there's generally going to be some programmable inputs and outputs that you can put into that controller. And that's where you got to make friends with your local distributor for that particular compressor because,
And ask for that when you buy
and
it.
well, either ask for it when you buy it or as the automation professional asking for hey, can I have the book on this controller so that I can, I can learn what I'm up against here. I'll give you a great example. Like on a Solaire, the newest controller they have, the SCS, there's plenty of programmable inputs and outputs on that thing for you to use, but you got to know how to access the menu and how to set it up and all that stuff. And once you know that, you're golden. And anybody that does this for a living could probably peek in that book for about 5 minutes and figure it out.
And it makes you look amazing in the field because other people won't go read it. And all you have to
Right.
do is believe that that is the manual. Like, if the part number says that that's really the part, like, this is from the internet. Like, and you are a genius and you can help people because of that.
And not only that, but most of your smaller compressed air distributor houses don't have a guy like me on staff.
Okay.
So most of your smaller compressed air distributor houses, they're a very niche industry. They understand how to repair that air compressor, how to size it properly, how to PM it. They understand all that stuff. But when you come to them and say, "We want this air compressor to talk to our plant DCS.
That's
We want this air,
integration.
right. We want this air compressor to report to this historian." They don't know. And unless they
They're
have a
not
guy like,
SCADA engineers. That's not fair.
well,
So,
I mean,
so you, yeah,
they wouldn't even know how to get started most of the time.
that's great.
Um, Most places they don't have a guy like me on hand. Now, some of your bigger OEM shops, like your Ingersoll Rand, for example, the majority of Ingersoll Rand outfits are corporately owned, and they actually have regional tech guys that go around that know how to do all that stuff and can take care of it. But if you're a smaller distributor for another brand X, whatever you want to say, there's a good chance that they don't have that capability in house. And so
Totally
someone from
true.
your audience, for example, can come along and come alongside them and say, "Hey, when you have these kinds of projects, I can help you. Like, I know what's going on."
So I know a lot of controls and automation people have great relationship with local automation distributors because when their customers need integration, right? They probably don't do that. But I don't know if automation people are thinking about having relationships with these air compressor distributors because I haven't
Only
really.
if they're chemical engineering backgrounds and they're sizing equipment from originally, those are the only ones that really have pretty good relationships because they're sizing the compressor or they're sizing the valves. Or I used to be a process engineer and I had a guy like you. His name is Lance Frederick. I still use him. He's like, shout out to him. But he was just showing me like how bad our piping was. He's like, okay, you see how your air pipes are above your valves and how rusted out all of your gauges are? That's because water falls down. And I'm like, damn it. Like, and we already piped all this. Like,
Right.
so yeah, I mean, engineers need to be taught. And that's really why I go back and say, like, engineers, when they're out there, they have to work with someone like you to show them that stuff. Otherwise, like, you're just going to keep making like bad design decisions. And like, if you don't have the PE ahead of you, like maybe he's too busy. If your supervisor, I mean, there's just a lot of reasons why things don't get built the best way that they should have been built. And then they have to be rebuilt. And working with people that are experts in that domain is super underrated. And the engineers don't know to do that. Be like, tell them you don't know what to do. This is the first time that you are trying to design. Someone told you to go get an air compressor. Like, what do? It's like, go talk to the compressor people.
Right.
And then you also don't know who's good and who's bad. And that's something that you'll just have to learn in your life. Like by using people, like not using them, but like, giving them an opportunity and then seeing what they are able to do for you in terms of, do they give you knowledge? Like, are they just trying to sell you the thing? Or do they be like, are they telling to make sure that you succeed with that thing? And that's kind of where you're coming from, is making sure that they succeed and making sure that they know that they bought something that has all these other capabilities and that they can use them and that you can enable that. That's amazing.
Right.
And young engineers think they need to know how to do everything already. And it's hard to accept that, like, that guy knows his product better than you.
Yeah.
So just talk to him about that product. It's
that guy doesn't have an engineering degree, but he knows way more than you will know, at least for another 10 years. It's going to take you to know what he knows. So it doesn't matter what his degree is. You better like respect. You want to get ahead.
And it's interesting that you bring up piping, because compressed air piping is something that nobody even really thinks about. But a properly piped compressed air system can be like, I mean, orders of magnitude 5, 8, 10% more efficient than a system that's not piped properly.
Save your energy. Yeah, you don't put 1,000 elbows everywhere. You lose all your shit.
That, like, I've made the Virgin Mary.
And even and even something as simple as what you just said about water's heavier than air and it falls downward. So
condensation,
So maybe instead of at all your service drops, maybe instead of coming out of the bottom of that header pipe, you come out of the top and you go up, over, and down. That way you don't end up with a bunch of water, at your process valve, your blow gun, whatever you're hooking that drop into.
They were rusting. The valves, we already paid the valves and they're rusting.
Yep.
Was that just the placement of the valve in relation to the pipe, or was that also like a lack of air prep, or
both? The fact that it wasn't, I mean, both would have helped not produce that. So but we had an air dryer.
Like a water separator.
We had a small desiccant air dryer. So maybe it wasn't working, but I mean, even if it does like produce way less water in the line, like eventually there is some water and it will condense. And so they will collect in low spots somewhere. And if those low spots are your valves, shame on you.
Indeed.
Well, shame on your process engineer. And I've done it myself, so shame on me. But I didn't know any better. I didn't know any different.
I said, what's some of the dumbest stuff you've seen out there?
Oh boy.
Pick your favorite.
You're like, no, why did you do that?
You don't have to name names.
Yeah, I won't name any names, don't worry.
No names.
No, I mean the same type of stuff Alicia's talking about. You've got you've got.
Or they didn't even put a dryer. They're like, it'll be fine in the South. Like, what?
Right. Or you got a refrigerated dryer, which is going to give you about a 38-degree dew point, and you're running that to instrument air in the middle of Pennsylvania, where it gets well below zero in the winter.
Okay. Yep.
So somebody wasn't thinking there.
So there's I would say like the dumbest thing, but what would you say is probably the most common oversight or things that is like, in your view, the most lowest hanging fruit, like just around in general that people aren't thinking about that they should?
Condensate drains.
Okay.
Mm.
Your air
So it'll
compressor
get
has
filled
one.
up.
Yeah, your air compressor has one. Every receiver tank in your system should have one. And
Touche.
when when I go to solve a moisture problem for a customer, I will glance at the air dryer and make sure that it's working. If that air dryer is working, I'm going straight for the condensate valves. And 9 times out of 10, you're going to find one that either doesn't work or it's plugged up with rust or
Mm.
whatever.
Yeah.
Okay.
Yeah. And you're just backing up into whatever. I'm just now thinking of like residential HVAC, but I've seen that way too many times.
So the interesting thing about that now too is, for the longest time, the industry standard was what's called a timer drain, which is basically just a little solenoid valve, and it's got a settable timer on it, and you can say every 10 minutes, I want this valve to open for 5 seconds and discharge all the water out of here. Well, now you've got the zero loss drains, which have the high and low sensors, and when they discharge, they only discharge water. You don't lose any air, all that. And a lot of companies now have taken that one step farther, and those zero loss drains now have contacts inside of them, that if that drain would go into alarm for whatever reason, that set of alarm contacts now closes, and you can monitor that remote. You can tie that
Tell them
into,
to go fix that. Yeah.
right. So you
When it
you could
happens.
yeah, you could tie that directly into a PLC that'll throw an alarm up on someone's computer somewhere. I've tied them back into the compressor controller so that when the controller sees it, it throws an alarm up on the controller. All those kinds of things that are available now that even 5-6 years ago weren't widely available anyway. And so even something as simple as like a lowly little condensate drain, you can really maximize what's available there and make that thing uh, make
Save
it work.
money.
Yeah,
Save money,
yeah, no,
downtime, and everything. Yeah.
right, right. Because I'll tell you what, I've drained some 4,000 gallon, 10,000 gallon tanks, and that's a lot of that's a lot of condensate to get rid of. Because the
They
thing the
weren't
thing
thinking about it. They just think air's in there, but water is in the air until it's cold enough, and then it's not it's not air anymore.
But I got to correct you on something there, Allie. It's not water.
What is it?
It's actually classified as oily condensate.
Yeah.
If you have an oil flooded screw compressor, it's classified as oily condensate. It's not water.
Oh
You
wow.
can't drain that out on the ground.
Yeah, you can't just dump that in the ocean, huh?
So so generally what happens there is, so customer calls up and says, I got this moisture problem in my compressed air system. Right? I got water shooting out of my process valves. I got my blowguns are now power washers. Um, I got a real problem here. And so
I've seen that though, the blowguns being power washers. That's kind of funny.
yeah, that's not a good day for anybody.
No.
And so you go out there and you go, okay, the dryer's working. So next stop is the receiver tank, and sure enough, you find a valve, drain valve that's failed or it's plugged up with rust or whatever. Well, now this moisture in here's got to go somewhere. And so what generally happens is the client scrambles and finds you as many 55-gallon drums as they can find, and you
Oh god.
you evacuate all that into 55-gallon drums, and then they're going to call a company like Safety Clean or somebody like that to come and dispose of it.
Expensive.
Yeah. Right.
So ideally you would just drain this over time into smaller like
Yeah, and just get rid
engine
of them.
oil containers almost.
Yeah, ideally you would have all of your condensate drains running to an oil water separator of some kind, whether it's a filtration separator or a dwell separator, something like that, that's going to keep the oil there and just discharge the water out. And most of them are EPA, DEP approved. Once they go through that treatment process, you can dump it right out on the ground if you want to. Um,
Nice.
Put it down a stormwater drain, floor drain, whatever you want. As long as you're keeping up with the maintenance on that particular thing, there's no problem with that whatsoever.
So you can assume they have those collection systems if they have a ton of compressed air, if they're doing it right.
Never assume. Never assume.
So I think he just proved that we cannot assume.
You're like, no, don't assume that, but like that's what they should have done. Okay, got it.
That's what should be the case. And
Yeah, they might be dumping it into the ground.
so they could be dumped. Yeah, I mean they could be running it right out the wall onto the ground. They could be running it right into a floor drain, which there's a caveat there, because if that particular installation has an on-site wastewater treatment plant that treats specifically
Mm.
oil, then they can discharge that. But if they
into their
don't,
own drains. Yeah.
yes,
Yeah.
into their own drain system that's going to go to their wastewater treatment plant to have the oil removed. If that's not the case, if they're discharging into a city drain or right out onto the ground, then yeah, it has to go through that oil water separator first.
Okay.
And strangely enough, there are even oil water separators out there now that are Modbus capable.
Oh, to tell you, like, yeah, either you're leaking or there's a
That it needs
fault or
service.
something's wrong. You're
To tell you,
overflowing.
yeah, if there's an overflow problem, if a maintenance timer is expired, something like that, yeah, you can get a Modbus registry and bring that right into your DCS system.
What do those look like? How big are those, like, footprint wise compared to like the compressors and like the
So
tanks?
so obviously the more compressed air you have, the bigger your condensate removal system is going to be.
Yeah.
It's actually sized by the total CFM of your system. They range
Okay.
anywhere from something about the size of a shoebox that hangs on the wall
Okay.
to something that's the size of the bed of a small truck, depending on
Cool.
how much
Yeah, yeah.
filtration.
Depending on the plan, how much, yeah. Okay.
Yeah.
Based on CFM. That's really cool. So you're not just a controls engineer, you're a process engineer.
I
That's
touch all
pretty
aspects.
cool.
I touch all aspects of
That's
it for
awesome.
sure. But I'll tell you this: uh, if I had my druthers, I would much rather connect air compressors and dryers into some kind of an electronic control and monitoring system than service oil water separators, because that's gross.
Dirty
Word.
jobs candidate. Yeah.
Yeah,
And
micro.
I don't think Mike Rowe's coming anytime soon, but
Not any.
and I will say this: as far as oil water separators go, they've gotten better in the last few years. Most of them nowadays are to the point where it's literally just a couple of filter elements you yank out, drop the new ones in, and you're done. Um, I'm from the old school where you had to get the shop vac and suck the oil layer off the top of the dwell tank, and
That's the OG way. Okay.
yeah.
What companies are selling those systems? It's not the same. Like Atlas Copco doesn't have a oil collection or oil separator, or how does that work? Like, which companies are actually producing those?
Okay, so nearly every compressor OEM in the world has their brand of
Okay.
compressed air dryer, filters, oil water separators, all these things, but they're
Okay.
all made by someone else.
Yeah.
Uh,
Yeah.
Yeah.
so
So it doesn't matter if you mix match those, because like you can make them. You can make it
right,
work if you size it right, or you can just be easy, make it easy, and just get all the same stuff under the same company.
right.
But it probably costs you more.
So if your compressed air guy is, for example, a sole air dealer like we are, and they're going to come out and they're going to say, okay, you need this size air compressor paired up with this size dryer, and then you're going to need this size oil water separator to deal with the condensate. Here's the price for that whole package.
Awesome. Okay.
If one so chose, you could break that out and say, well, I'm going to keep the Solar air compressor, but I want I don't know, a Parker dryer, and then I'm gonna use this Beco oil water separator. I mean,
If for some reason somebody wanted to do that, that seems like a lot of more paperwork where I could just write you a PO, right? And then I buy all the stuff, which I think people do prefer, but people do all kinds of stuff. So you never know what they're going to do. You'd be like, yeah, I can make it easy for you, or I'll just sell you one thing if you want it.
right,
But then it's not my fault if other stuff doesn't work, because I was trying to give you a functioning solution. But I'll be there to help at a
you
rate.
A
you
number
would
of times people will try to save money on
yeah.
hardware only to spend 5 times as much on labor making it work.
Yeah.
Is hilarious to me because it happens so much.
I was
People are
just
like,
gonna
well, it's
It's
cheaper to do it
brutal.
this way.
you
You're
would
like,
not,
it's not. It's not. It's gonna be so much harder this way.
you would not be surprised how many times I go into a place where we came out and quoted a system for them, and they thought, oh, I can get this cheaper off the internet, and it ends up being stuff that's all mismatched and nothing works together,
That's the
and
world's economy.
well, and so the amazing thing about it though is, so let's say for example you've got a guy like me comes in and I say, okay, you need a 750 CFM air compressor to run your plant. Here's a quote for a compressor, dryer, and oil water treatment system. We're good to go. And you might look at it and go, well, I like the air compressor, but I'm going to find this dryer cheaper somewhere else. If you don't know how to properly size a refrigerated air dryer, how to apply correction factors and all that, you're going to put a 750 CFM refrigerated air dryer right next to that 750 CFM compressor, and you're going to have a shit ton of water in your lines.
Ooh. Oh, because they're going to do 1-to-1. They're going to be like, oh, that's the size. The size is the size. We're good. Oh, and I bet they do that all the time.
Happens more
I've seen where companies, and this is just like, I think this is just like a company problem, like depending on the company, but like they will lose their engineers and their people that are left. So like purchasing people, like they need to fulfill orders. So they will look at things and just be like, we sold this before. It has all the same words. Let's just give that to our customer, and they do not, and it has to be an engineered thing. But because
right.
all the words are the same, they're like, let's just sell them exactly that bill of material.
Yeah.
And it's so wrong. And there's just, and I mean, you can't, how do you catch that? If you're like the CEOs or like of these companies, how will you catch that? You don't until you just come down on your engineers that you do have left and be like, what the hell's going on? But yeah, customers, like, you can receive from companies stuff that wasn't sized right, and like, so that's why there's supposed to be an engineer to like talk to be like, who did this, who said this was
Right.
good. And sometimes the company was just trying to make the sale and
Right.
they sold it,
And then it turns into an
and no one
absolute
stopped them. Yeah.
and then a guy like me walks in and just goes, oh my God.
Yeah, it's like, we literally can't use any of this. And they'd be like, he's just trying to sell you the something more. It's like, okay, then just keep shooting water everywhere, like, or whatever. It's like, it's at some point that someone gives, but like, yeah, that's just like a really bad situation to be in. And it happens to companies because they can't retain their engineers or their technicians. It's technicians too. They know how to do a bunch of stuff that if the technicians and your engineers disappear, and you need someone to check the orders before they go out, and all your people are just trying to copy. It's called copy and paste sales, right? I think that's what
Right.
I want to call it, that, because it's like, it's something that's supposed to be engineered and checked by an engineer, but they were like, we are good enough without that. We're just gonna look at the wording and like, we're good to go, and they're just not going to ask the right questions, and then they're going to sell a lot of money's worth of something, and then it won't work. It's not meant to work in that situation because it wasn't, like you just said, they just went 1-to-1 because it sounded great. They're like, well, that's what
Right.
he did. He just sized it based on that CFM. That's what I'm going to do. Yeah, that's terrifying. So warning to everyone on both ends of this, right? Like, if something's going on with your equipment that you just bought, it could be electrical, it could be wiring, it could be mechanical issues, or it could be it was not ever sized for the application correctly. So you don't even have the right item, because I've bought pumps and they were cavitating because I put like elbows in places that they shouldn't have been. But like, you can buy the wrong size impeller for a pump,
Oh,
and
yeah.
then the only solution is going to be a different impeller, or sometimes even worse, your only solution is a different pump body. And that's your
Right.
problem. Like, and you can replace every, like, the PLC and the HMI and like all this shit, and you're like, it's never going to work mechanically if it wasn't
Right.
sized properly. And I think that freaks people out, that idea, because they're just, why would it be the wrong size to begin with? It's like, because you don't know how it got sized and how someone decided to put it there. Like, that's what engineering is. And
Right.
so if someone doesn't do that engineering, even if it's not an engineer that does it, but if someone doesn't do that engineering, that knows how that engineering works, yeah, you're just going to put stuff in places that look like, well, everyone else has always done that. They always put a pump here and a tank here and a thing here, and it doesn't work, and you don't know why. And it's because, well, there's parameters that you didn't know about that went into that sizing of that stuff. So everyone, like, be warned. Like, you don't even know if the thing is even right. So yeah, you got to call experts like Rob to come in and be like, tell you the bad news.
Yeah. Well, and materials is a big thing too. I was at a I was at a fat rendering plant many years ago. I don't know
Yummy.
Oh.
Yum.
plant, but man, you get if you don't have a strong stomach, don't bother.
I was gonna say that sounds like it smelled lovely.
Yeah. So um, I got called in there, and their complaint was our refrigerated dryer keeps failing. It lasts our refrigerated dryers will last about 6 months, and they fail. And been going on for a couple of years now. And so I go out there to look at this thing, and they've got the air compressor shoved in this little room like they always do. But I walked into that room, and I turned around and walked back out, hacking and gagging. And I asked the guy out there, I said, "Does that room always have sulfur dioxide in it?" And he says, "No, but it does get flooded from time to time." And I said, "So you've got a refrigerated dryer in there that runs all copper tubing in a room that gets flooded with sulfur dioxide, and you can't figure out why this dryer's failing?"
Wow. Wow.
So
That's where, like, you just that and kind of you made this point, but like that's where you need somebody that specializes in that thing, and to walk into that room to have that situational knowledge because it's obvious to you clearly, but
right,
just to people that don't have that, I don't even know want to call it expertise, but like just that experience to be able to call that out that easily. This reminds me of a vision application that Courtney had talked about where there was desiccant dryers all around and the air was so dry that the CCDs of a camera were malfunctioning.
Wow.
Yeah,
That was a deep dig.
and that's another thing where like if you're gonna piecemeal together a bunch of components that the specs say they should work together, but maybe they're from different manufacturers, those spec sheets are also, you got to take them with a grain of salt, right? Because they're about performance under certain conditions. And one spec sheet
Are
is
you in those
another
conditions?
person's spec sheet as it relates to the tolerances they went through in their testing, what conditions they're really, specking when they're specking their ranges of things. So working with someone that like is used to and is familiar with these product lines and has seen them work together, not just on paper, but in practicality, I think is oftentimes kind of a missed area of value that makes a lot of sense when you think about it. Is just the fact that this person has put this stuff together before and they know that it works. You can save yourself a ton of cost that way because you can spec all kinds of stuff together that on paper even says it might be right. But at least I've heard enough from my engineers about like what they trust about specs from certain brands versus others. Everybody has their own little flavor of doing things. Do you find that in the compressed air world that everything kind of works together between different OEMs, or are there some kind of finicky things that kind of with experience you learn not to pair this thing together or that?
no, I mean, you can make about anything work together as far as
With money and time.
Yeah, right.
And enough fittings.
yeah, as far as this or that brand or whatever, especially when you're looking at pairing up, like say, an air compressor and a dryer or something. I mean,
Yeah.
that compressor doesn't care what brand that dryer is. The dryer doesn't care what brand the air compressor is. As long as everything is sized up appropriately, you should be fine. Where it gets a little hairy sometimes, and this is my niche. This is where I kind of shine, is bringing multiple different OEM air compressors under one control system.
Oh,
Uh,
yeah.
that's where it gets a little hairy sometimes. Um,
Because they
there are
might
some
not match like CFMs, or like they might not match in certain like parameters, or like why does it get hairy?
so there's a lot of there's a lot of really good aftermarket compressor central controllers, and then there's a few good ones. And so if you've got a room full of, if you got a rainbow compressor room basically that's got every brand under the sun in there, and you want to bring all these under one central controller, yeah, there's definitely some bugs, some glitches, some temperamental things about those air compressors that you're going to
So they
need to
won't be
know.
one to one.
Well, I'll give you a prime example because I just ran into this not too long ago. Gardner Denver compressors, they use a controller it's called the AirSmart controller, and the particular central controller I was using communicates with that AirSmart via Modbus, which makes my job incredibly easy because I don't have to deal with a whole lot of stuff other than just hook up the Modbus cables and a couple of little sensors for the interface, and I'm good to go. But if any fault is present in that controller, it ceases Modbus communication. So
Okay.
so here I've got this controller
Can handle both.
that I just hooked up to this system, and it's not talking. And I'm like, why is this thing not talking? I've gone back through all my prints. Polarity's good. You know, did an idling voltage check on the serial bus. Everything looks great. I'm like, why is this thing not talking? And then I realized I had a service timer that was expired. Reset the service timer. She starts talking.
Oops. Okay. Little intricacies like that. That makes sense.
Yeah. Little things like that. Yep.
You had said earlier, or when in the beginning, that you were an auto mechanic first.
Correct.
My little brother is an auto mechanic, and I'm trying to think of all of the ways to sell him on automation. One of the ones is that I was like, your customers, and he works on BMWs, and I was like, your customers, right? Like your high end customers are like, I don't know who owns doctors, lawyers, whatever, like rich-ish people or people that want to look rich, have those cars. But like my customers are corporations. Like, what if I could get you working on like a business that has a lot more money than a surgeon or a lawyer? Like, you know, so I was trying to sell him on like the more money, because he's like, well, I want to do racing. And I'm like, cool, won't you have more money so you can do more racing? Isn't racing really expensive? Like, but you got to pay a bunch of, so have you seen other people come from mechanic backgrounds, and like, what do you think helped you as a mechanic to like just jump into some of that? And he also likes, in the BMW world, the electronics. That's why he was hired by like an OG like BMW mechanic who doesn't want to do the electronics, the new like BMW electronics. So my brother's name is David, is into that. And so I think there's probably a lot of like electronics savvy mechanics out there that we could just go take them. What do you think about that? How would you entice them? Yeah.
Well, for my personal journey, I guess you could call it, I got out of auto mechanics because I got sick of people.
Okay. Okay. That's a good start. Okay. Because that's general people who want to complain about their own money, so they're gonna fight you.
And like, every customer, you know, you don't come in for your car all the time. It's all new people all the time.
And they're upset because now they got to pay a bunch of money that they weren't going to pay before. They didn't plan it in their budget. That's not in their CapEx budget.
Right. But it wasn't even so much that. What really kind of soured me on working on cars was, again, I'll give you guys an example of this one customer I had that I just was like, this guy was actually the straw that broke the camel's back. This is where I said, I'm out. So it was an older gentleman, brings his Cadillac in, and he says, it's running hot, put a thermostat in it. And I said, okay, you know, we'll get to it later on, probably later on this afternoon. And this was, I was a shop foreman at the time. And so my guy brings it in and parks it, and happens to notice the puddle of antifreeze it leaves on the ground. So of course he investigates, and he says, I can put a thermostat in this thing, but I don't think it's going to do much good because the water pump's leaking. And I said, okay. So I called the guy back and said, you know, hey, we noticed the water pump's leaking. That's probably the more likely cause of the problem with this thing running hot. Would you like us to take care of that for you? And he says, damn it, I said put a thermostat in that car. Don't you touch nothing else. Nothing. Okay, dude, your car. We put a thermostat in it. We rolled it out the door. He comes, picks it up, pays his bill. We're all good. He comes back the next day and says, you put a thermostat in my car and it's still running hot.
No kidding.
They're like, yeah, man, I know.
Yeah.
Yeah, but like, so did they try to punish you for that? Like, or what happened with that? Like, because my brother definitely tells me that, like, yeah, people try to come all the time. He has to like take their cars from them, like because you could put a mechanic's lien on some of these people, because they didn't pay you.
Oh yeah. So no, I mean, with that guy, it pretty much just ended up being like, well, hey man, you know, we tried to tell you it needed a water pump and you said no. So if you'd like us to replace the water pump, here's the estimate to do that. Otherwise, go away. And he decided to leave mad, and it was, I mean, that one guy right there probably ate up half my day that day. And it was after that,
I just sucks.
I'm gonna go find something else to do.
Yeah, because you don't know when the next guy's gonna come and take another half of your day, or lady, whatever. There's Karens.
And there's probably no end to ways people can abuse their car and then have no accountability for it. It's just
and then yell at the mechanic. Yeah,
you don't know like that guy's prior experience, because I have gone into get my wheels aligned and been told, "Oh, do you know anything about brakes?" And then I say no, and they're like, "Oh, you need all new rotors and pads and everything." Right? And then, I was like, "Well, let me call my boyfriend first." And then, we don't need any of that, right? But I was an easy target, and I didn't know enough to know whether I needed that or not. So when I was looking for an auto mechanics shop when I lived alone, basically my benchmark was, are they going to try to sell me something I don't need or not? And do I feel comfortable with that? So I actually found one where I had a rather loud noise in my car. And the guy said, well, it sounds terrible, but you don't actually have to fix it. And that's, I was like, okay, I think this is my shop.
Yeah, that's nice.
So, maybe
that is the stereotype, right? Like the stereotype is that like mechanics are going to try to tell, especially if you're not a man, they're going to probably, and that's not all of them, but like they might try to sell you stuff that you don't need. And you just say, no, I don't want to buy that. But they're allowed if it's going to kill you. If you're like, no, I don't want you to fix my wheels. And if it could kill you, they can just be like, you can't have the car because you're too stupid to not kill yourself. We literally can't let you because you're going to literally fucking die. And then it's our fault that you died because you were stupid enough to bring us the car. Have you ever been in that situation? Have you ever seen I literally can't let you take this car because it will kill you?
So laws like that vary from state to state. When I was a mechanic, I was in Nebraska. And the state of Nebraska plays it very, very loose with automobile type stuff. I mean, there's no.
Okay.
You probably have the personal freedom to go kill yourself in your vehicle if you want.
Like, no thread on your tires. Like, no oil, no thread. Like,
when I first moved to Pennsylvania, and they're like, you got to get your car inspected every year. I'm like, what are you talking about? And
you're in the north, son.
Yeah, Nebraska, no such law existed. It was, the front tire could be sitting like this, and customers, no, don't fix it. I'm driving home. Hey, see you later.
But I think overall, whether you're an auto mechanic or in the automation world, like in general, if you have the attitude that you may have something of value to learn from those around you, whether they're people working for you or you're working for them, I mean, it just seems like common sense. But I can imagine like that same feeling or that same thing could drive you to quit a job in any industry, really, which is just people being stubborn and making decisions against their best interests, even though you did your best to try to help them. And I think that's a lot of this short-sightedness, people, if they have been taken advantage of or they don't understand that the value in being vulnerable enough to actually just have a dialogue and learn. And I hear this a lot from the engineers too. Like engineers feel like they need to know everything, so they're not going to open up about whatever issue they're having to their vendor, for instance, because also historically, maybe the vendor will just use that to take advantage of you to sell you more, right?
Right.
And it's like, but long-term good relationships for business actually hinge on you being able to tell the full story to each other and come up with the best solution, right?
Right. Yeah. And I mean, unfortunately, you see that in the compressed air world as well, where, nothing is a priority until it's an emergency, and then it's the only priority. And
that might be all of manufacturing. What is the problem? Like,
I don't know, but it amazes me how, people can neglect the compressed air system and they don't care as long as there's air in the pipes. As soon as there's no air in the pipes, that is the only thing that matters.
Yep. Because downtime, right?
Now no valves work. Can't do anything. Whole shutdown.
And now it's everybody's problem.
Yeah.
Are you seeing a bigger trend in as Industry 4.0 and connected factories are becoming more of a thing? Are you seeing that as a trend, the places you're going? And is that making things a little bit better for the compressed air? Are they tying that into their smart factories, or are they forgetting it altogether and making everything else smart?
So again, as we talked about at the top of the show here, this is where your audience is going to get to play a major role in that, because for my company, I can do that. if that customer wants their compressed air system, their dryer, all that reporting back to their SCADA system, to their DCS, to their whatever, I can do that for them. But not a lot of distributors have a guy like me on staff.
Yeah.
And that's where your audience can come in and make friends and say, okay, we have this mutual client between the two of us. They use me for my automation stuff. They use you for compressed air stuff. We need to become friends here and get these compressors talking to the system.
Hell yeah.
The story that I always like to tell with this is, if you think of a manufacturing plant where they could have every bit of connectivity in the world, but if they're blind to the compressed air system, then what happens is the operator's doing his thing, right? He's running along, he's operating, doing whatever. And all of a sudden, say a sludge pump or something stops working. He doesn't know why it stopped working. All he knows is my sludge tank's filling up and the pump's not responding. So now he has to call maintenance. They have to send somebody out, look at it, and they go, we got low compressed air. Well, now somebody's got to go look at the air compressor, figure that
That's
out.
a waste of time.
Yeah.
Looking at the sludge pump at all. Yeah.
Right. That downtime could be substantial. Now, on the flip side of that, if that operator gets an error saying, hey, compressor one just shut down, well, how much time did we just save troubleshooting? We don't need to worry about looking at the sludge pump or anything else. We can send the mechanic right to the compressor room.
Yeah.
Now, if you take that one step further, even, because a lot of these compressors now, the Modbus registry is extensive, and you can not only monitor for faults, but you can monitor for specific faults. So now that compressor shuts down and it sends an alarm up to the control room and says, compressor one down on VSD fault, heatsink overheated. Well, now not only do we know to send maintenance to the compressor room, we know to send the electrician to the compressor room, and we can get this thing solved even faster. So, yeah, I mean, it's a big downtime saver when you look at connecting all that into the central control system like that.
Yeah. And now they do preventative maintenance, right? So like to try to get some companies have an MES system and they're actually sending now work orders to do maintenance on a compressor, because they know that it's now vibrating different than it was vibrating when we first bought it, or it changed over time and now its bearings are like, something's wrong, we got to go look at it, or compare it to the other compressors that are running if you have more than one. So yeah, we're trying to do that, but yeah, that definitely our audience can help with. That's industry 4.0, and now actually no, industry 5.0 is using AI and machine learning to take in all the data that is already can be connected from SCADA and from all the instruments and from all the systems, other manufacturing systems, not just like technical systems, but like ERP and HR systems, and tying all that all together so you can know crazy things about your company down to the sensors themselves, and how much it's costing, how much a piece of equipment costs you, and how I think people say that like when they first put an OEE, which is overall equipment efficiency numbers on things, like people had never seen those numbers before. So just by virtue of having a number to look at, they can increase that, because they were like, oh, well, yeah, I guess we could run it. We could turn it off less. We could, run it longer, and then put better numbers to that. And what does that do for the, bottom line? And does that help? And yeah, it is working to try to get. So data is huge. And I'm really glad that that's kind of the premise of what you wanted to even talk to us about was, yeah, I know all about compressors. I can fix your compressors, but let me help you actually monitor your compressors so you break them less often. And or let me sell you the compressors because I helped you break less of them. Oh no, yeah, we can't. Oh no.
Uh-oh.
It was definitely great to talk to you though, even though you can't hear us anymore.
There we go. Hey,
oh, there you are.
All right,
I fixed it faster that time.
Good. Well, then we have time to ask you our last question. I was about to go in there and say a whole thing about how we've been monitoring temperatures in grocery stores, fridges and freezers for like a decade, and predicting compressor failure just by looking at the patterns in the temperature. But the other thing is, like you said, just measuring it can be a huge savings just in and of itself, because oftentimes when people are not measuring or they're not realizing that there are multiple different years and manufacturers of equipment, all of their temperature sensors are in different states of calibration or maybe out of calibration. Once you just start to look at it holistically, collect the information and start seeing the patterns, you can adjust the operating conditions, and you'll see right away, like some of these need to be tuned up. I mean, just basic small things that if you don't have eyes on it, how would you even know? So you can extend the life of your equipment a lot.
What gets measured is what gets managed.
Exactly. So even just the low-hanging fruit of before you even start doing any kind of AI predicting of anything is you can usually lower your energy usage right off the bat just by starting to actually take a look.
Right.
And then you can start to make those better maintenance decisions, like who do we bring based on the fault codes, and what do we bring to fix, right? And we've been able to make those predictions. Like, let's say we have a service route of the HVAC, the refrigeration technicians, just being able to bring the right thing to the service call and not have to drive 2 hours back to get some spare part or whatever. I mean, that in and of itself pays for the cost of the monitoring within the first couple of months. And usually that's not even including the energy savings that you end up getting, just being able to run your equipment slightly more efficiently. And I don't know if it would be the same for like plant compressed air and those compressors, but I think
it's the same idea. They're gonna go to crap over time.
Yeah, absolutely.
They don't run forever with nobody touching them. That's impossible.
And you don't need to go straight from having no clue and no visibility to AI telling you what to do. It's like there's a great middle ground there where you can get a lot of gains before you go that far with it. One more question, and then before my actual last question, can you upgrade the controllers on old compressors to get that more fun without actually having to replace the whole system? Is that
absolutely
part of what you do? Okay, so like you said, even if you have like rainbow of a bunch of different ones, you can unify them under the same control system and start to get some of that holistic visibility.
So there's a couple of ways to do it. I've actually won awards doing this kind of work. So you can, for example, trying to think of the last time I did this was in an installation where there was 1, 2, 3. Yeah. There was 4 brand new LG air compressors and 2 older compressors that had been there a while. And yeah, we took the LG Neuron 3 controllers that were standard on the new compressors, retrofitted them to the old compressors to basically make it easier on the maintenance crew to only have to learn one controller now.
Nice.
Thinking about the maintenance crew and the operators.
That's
don't do enough of as well.
Yeah, they don't want to learn 6 different menus.
Right, and that's actually very easy to do. At the end of the day, the air compressor itself doesn't care what controller is on it, as long as you're giving, as long as you're giving the right inputs to make the controller happy and giving the right outputs to run everything. It doesn't care.
But a Siemens PLC does care if it's an Allen Bradley HMI, and it just won't do it. Have you ever seen Allen Bradley on these systems out there, by the way?
So, funny you should ask that.
Maybe like your controllers talk to Allen Bradley controllers or something like that?
So,
or other way around.
So Cummins Wagner has a sister company called EPS. It's Engineered Process Solutions. And whenever we buy things from them, like for example, like a flow controller or something like that we'll buy from them, it's all Allen Bradley, Rockwell, all that stuff.
Okay. Interesting. Okay.
Interesting to know.
Yeah.
And then
so they have a deal with that makes sense for them. Or their engineers, it makes sense for their engineers. Because most engineers in the US, controls engineers, know how to use Allen Bradley, like ladder logic. Studio 5000 or RS Logic's 5000 or 500 or 5.
You can assume most stuff probably speaks EIP in the US too.
Yes. Like Profinet.
Yeah, that one's a little harder.
Yeah. Well, and that's the other interesting thing as far as from a monitoring control standpoint is if that air compressor or that dryer has a microprocessor controller on it, there's a very good chance it speaks Modbus right out of the box.
So it's that common. Okay. That makes sense.
Yeah.
And Modbus is that easy, and people know how to use it, like, so it won't die.
Yeah, it's not going to go away.
Modbus is always like the fallback
It's
option.
so easy,
Like,
yeah.
it'll work.
Yeah, Modbus is great. There's some manufacturers out there that are actually switching over to industrial CAN bus.
Okay.
I've heard that.
Which, as far as I'm concerned, I mean, is it superior to Modbus? Sure, in a lot of ways. Is it as widely accepted as Modbus? Absolutely not.
No, it's just the simplicity and the fact that everybody knows how to use Modbus and has always used it forever. And it doesn't need to be fast because they don't care about those speeds. Like, although if you talk to like IT people, they're like, oh my God, those are atrocious speeds. It's like, yeah, but our stuff doesn't need to talk the same speed that your guys' stuff does.
Right.
Yeah. Unless it's like super critical, but yeah, no, we don't need milliseconds. Not always. Sometimes in machining, sometimes. I'll back off because like in process control is when we don't really need that. Unless it's like a really temperature critical thing.
Well, and most definitely in compressed air, we don't need it that fast.
Yeah.
Oh yeah. So that's why it makes sense Modbus to be used in lots of skid, like process skids that you can sell to companies that have their own controller on it. Most likely at least carry that. And then if you ask or buy, you can get Ethernet. But it's not just necessarily like automatically Ethernet, but like you're saying, it probably is automatically Modbus just available. It's just there because they've had the controller forever and there's like no reason to take that out. They could just add Ethernet and it's cheap and you have the parts. Yeah.
Well, yeah. And it's easy, when you got you got a compressor room with, you got 5 air compressors and 5 dryers and a handful of condensate management systems. It's easy just to go through and just assign all that stuff its own Modbus node and connect it into the PLC. And now any one of those controllers sees, you can now monitor, and in some cases you can even control. It works out nice. I'm trying to think, the Atlas Copcos, for example.
Those are nice.
So Atlas Copco is actually one of the companies their controllers are industrial CAN bus out of the box. But they do sell a really nice, easy to use Modbus gateway. And like on a variable speed Atlas Copco, for example, you can let that thing run of its own accord. And then suppose at some point in the process, you want something else to determine how hard that air compressor runs. Well, you can control that via Modbus on that thing. And it's actually pretty easy to do.
Interesting.
So,
and you can get Modbus if your system isn't Modbus and you need Ethernet. You can get a gateway and talk all that Modbus into another system, and just let the Modbus system talk Modbus to itself, and then you start reading some of it. If you want to grab that information, and then you don't have to buy all new everything, so everything is Ethernet, because you could just leave everything Modbus and gateway talk to Ethernet and get that data anyway. Not at the speed you want, but.
Well, I've done a handful of Modbus RTU to TCP/IP gateways. It's not tough to do.
Yeah.
And
Modbus TCP. Yep, those gateways, and people want to see that. They just want everything back to RJ45 for whatever reason, for monitoring, because they have whatever their central thing is, and they want their historian or whatever is probably Ethernet. So yeah, just get that gateway and like make sure. But the idea is that like, these systems don't just talk out of the box, but you can get people like Rob and integrators to program you gateways, or your own internal people. And you can have, Rob's help. But you have to go out there and talk to these people and get the skinny, get the down low, and be like,
so
what are my options?
I'm gonna go move to our final question. Rob, can you tell us if you have anything exciting coming up, anything that we should follow you for, and then where can people get a hold of you and follow you? And I guess in that sense, if they're automation integrators and they want to learn more about how to work with compressed air, can they come to you, or what are your suggestions on their next step if they found your suggestions today interesting?
So as far as exciting stuff coming up, I get stuff thrown at me all the time. Just projects that I know that are coming up right now. I've got another central controller install coming up in the near future, which is just bringing 3 Sol Airs together. So that's not going to be anything too tough there. I've actually got a bag house system coming up that I'm in the process of quoting right now.
Like a dust collector?
Yeah. So the customers got plant air running to the baghouse dust collectors.
Okay, to shake the bags.
Yeah,
Okay.
and sometimes depending on what they got going on, sometimes plant air is a little bit low and they don't shake as well as they should. And so they came to me and they said, "We've got this 150 horsepower compressor that's in mothballs over here. We want to unpack it and tie it into the baghouse system." And I was like, "Whoa, pump the brakes here, buddy." I said, do we have any specs on this thing? He says, "Yeah." So he sends me the specs. This thing wants 50 CFM at 90 PSI. And I'm like, "You realize that air compressor puts out 600 CFM?"
I've seen that where you greatly oversized something else. Like, well, it was on sale. Like,
but then you end up spending that money in the operation like really quickly.
You don't need that. Yeah.
Air compressors are a huge cost.
So they're dead set. They're going to use this air compressor. And I said, "Okay, if this is what we're going to do, let's at least be smart about it." And so what we're going to do is we're going to tie that air compressor in directly into the baghouse system, but then we're going to put a loop back to house air with a reverse flow controller so that all that excess air that baghouse doesn't need is going to get fed to house air.
Oh, okay. Yeah. So
nice.
You're not just wasting all that extra air that you're making.
Well, and we're not just cycling that compressor constantly, load, unload, load, unload, load, unload.
Yeah, yeah.
We're just going to tell that reverse flow controller to keep that section of pipe at whatever 90, 95 PSI, and then it's going to regulate and dump the excess out to house air.
So that's why you need somebody that just kind of knows what's up with these things. Very cool. Well, if people want to, make more friends in your industry, or connect with you, where can people find and follow what you're doing?
So at this point, I am only on LinkedIn. LinkedIn exclusive. I do have kind of everything in the chute ready to launch on YouTube. I just haven't gotten there yet. My goal is, I think once I hit 500 followers on LinkedIn, that's when I'm going to launch YouTube.
All right. So action item for everybody that's listening. Find Rob on LinkedIn, and there will be a link to your profile in the guest profile for this episode. It should be in the show notes as well. Go ahead and click connect, right? You're open to that, Rob? Or is it a follow button that you have?
Yeah, follow, connect, whatever. I got both. I don't care.
Yeah.
I actually I enjoy the connections because if you just follow me, that's cool. But I like the connections because if I can see what you're into as well, you don't know what kind of cool stuff is out there that you don't even know about.
No, exactly. And I'm all for, keeping your network to people that make some sense. Like, but anybody that's in this industry or, in the industrial controls integration, there's so much to learn from those adjacent fields. That I've not been picky and like only connecting with people that do the same kind of thing. But as long as they're in the industry and I can tell that we like have, some things in common to talk about or discuss, then it's been a huge value to open up the network to some people that I don't know, as long as we have that commonality, right?
No, I will add 2 caveats to that. I'll connect with anybody, but
unless we sell you crypto.
Don't try to sell you anything. Don't pitch them.
I don't care. I don't care about that either. I could ignore a DM as good as anybody.
Okay.
But no, there's 2 things that'll cause me to disconnect from somebody really, really fast, and that is liking every political post you see, regardless of what side of the aisle you're on. I don't care.
Yeah.
Keep that for Facebook.
Yes.
So
agreed. 100% agreed.
Yeah. If we connect and all of a sudden my feed gets flooded with a bunch of Trump or Kamala stuff or whatever, like we're disconnected.
You're like, that's not what I wanted. I want robots.
I 100% agree. I think it messes with like the job, no matter what job it is, and it's like totally unnecessary. And at the end of the day, we are going to be stuck with each other in the workforce. So there's no reason to bring that crap up in our job. That's stupid.
Right.
Like so stupid. It doesn't matter what your opinion is. Like having that like mess with like the job you're doing is like there's no reason that should be messing with the job.
Yeah. The other thing that'll cause me to hit that disconnect button real fast is if you're liking every thirst trap you see on LinkedIn.
Yep. Yeah. I've seen those too. Those are hard, damn it.
That's like all of their interest in, like, all the posts they've interacted with. You're like, huh.
And I can imagine that there will be some folks in your network that see that. I have worked very hard to get both of those things off of my feed.
Me too.
Yeah.
And exactly. And the only way to do that is to unfollow people that bring it to your feed.
Yeah.
And I always have the thirst traps on LinkedIn are hilarious because it's not overt like Instagram, right? It's more like, here's my cleavage, and oh, by the way, did you know there's still water in the pool in the Titanic? Follow me for more amazing facts.
Yeah, most of them are quote unquote subtle. Although I saw one, it was like, I think it was and I have mad respect in some ways, but I think it was a lady farmer like posing in a corn pile.
That was the one that I like will never forget.
Me neither. And I'm like, dude, I want to like.
No, she's like in a silo. It's like,
yeah,
in lingerie on LinkedIn. I mean,
power to you for being a farmer and getting to do that. You clearly have control over your own destiny.
You farm lingerie? Like,
super. I don't know what to do with that. I don't know.
Right.
That's no fear.
There was corn everywhere. There was corn kernels everywhere. It was so scary.
That's my only two asks, please. It's no politics and no thirst traps. Other than that, like,
with
I love learning about.
We
go without corn kernels.
That's just been my answer to everything lately. I came here for the robots.
Yeah.
Please leave me out of all the rest of it.
Well, wait till they start robot cleavage like shots, and then what are we gonna do? Like,
yeah.
Well, thank you so much for joining us today, Rob.
This was a good one.
We really enjoyed this conversation. Thank you for being a part of our network and being willing to chat. And that's what this is all about.
Stuff.
So,
yeah.
I hope that you have some people reaching out to you after the show airs that also want to chat with you about this stuff, because that's why we're here.
Yeah. As far as the integrators and stuff in your network, I mean, if you got questions, you got a system you're trying to hook into or whatever. I mean, I don't think there's.
You should rebrand yourself as a compressed air guy.
What's that?
You should rebrand yourself as the compressed air guy, like the go-to guy.
Well, you'll be the go-to guy in our network, that's for sure.
Yeah, I have to say, you're my go-to guy now.
Yep. So watch those
air. Think of Rob.
People don't ask Rob for free work, but sometimes you can start a relationship by giving some great free advice back and forth. But we've also found this to be, a blessing and a curse of getting your name out there. Is a lot of people just will get in your DMs asking you to work for them for free. We don't respect that. We do respect people adding value to each other and asking each other for help in respectful ways, being respectful of each other's time and talent.
Yeah, and I got no problem pointing people to resources and things like that, because I mean, obviously, if you hit me up for a Modbus registry for such and such air compressor, well, obviously I'm not going to have that, but I can at least get you pointed in the right direction, or we can discuss capabilities, things like that. I mean, I got no problem helping somebody out if they're earnestly trying to to get something going and they need a push in the right direction. I'm all for that. But yeah, like Nikki said, I'm not coming to work for free.
Yep. Awesome. Appreciate it. Thank you so much for joining us in the middle of a hectic day, Rob. We really appreciate it, and we look forward to staying in touch with you. Thanks for being on the show, and have a great rest of your day.
Thanks. See you guys.
Bye, guys.
Thank you.